I'll do it in a northern accent, eh?
Go do it.
Okay, we're going to draw your favourite sofa. You're alright drawing these sofas, eh?
Maybe you'd like to explain why it's called sofa?
That's a secret of the club, like.
South Africa.
South Africa? It's a sofa, because what you know so far.
See, it looks like more of a high five. Like, the two speakers.
It looks like the worst front of
looks
a
like
car
it's got a head like
on ever. That's what I was thinking.
It's got like breasts.
Start that again.
Right, well, we need to start again. And there's can't do a daft accent anymore.
Yeah.
Right, at least you were clean about it, it's not sweary words.
Exactly.
It looked like yours. Definitely neat stuff. Alright, so AI topic. AI stands for
Artificial intelligence.
so artificial intelligence. Okay, so we need to know a kind of definition of AI. Definition is
A kind of program that would usually need human
good.
expert knowledge.
Close enough. Machine intelligence, robotics, computer software, whatever it is. Machines doing jobs that, if done by humans, would require intelligence to do so. What we'll get asked is, what are some different aspects that we would say, well, it requires intelligence to do such and such an activity? So what are some of them?
Ability to learn.
Ability to learn, like it, yep. Ability to learn. Yep.
Problem solving.
Problem solving, excellent. Any others?
The ability to communicate.
Communication, yep. Any more?
Adapt to new environments.
Yep, so adaptability, new environments. Looking for another one, it's just one word. Creativity, good, right, they're easier. But although perfectly glad the other ones. Okay, so these are all aspects of intelligence. So why is it hard to define intelligence?
It's always changing.
Intelligence is
So
always
many
changing.
aspects to it.
Good, okay, so there's so many aspects of intelligence. If you give one description or you give it one activity that requires intelligence, we could pick an aspect of intelligence that doesn't fit into that category, I guess. Why does that make artificial intelligence, well, it's loosely based, but how is AI hard to define?
Because it's always changing.
Yeah, so always changing. The field of study is always changing. Anything else about it? That many people involved in it?
Oh,
Anything else?
they all have different they all have different takes on it.
Takes, what do you mean?
Like their opinion.
Opinions, alright, good. So it's the backgrounds that people studying. So a biologist has got different specialisation compared to somebody who has a computer science background, and psychologists. So they all see it from their perspectives, from their own background of learning. So their description of it and their definition of it is different as well, but it's always continually changing. So one of the first things we spoke about was the early success. Now, what was the early focus that AI concentrated on?
Games.
Games. Now, why choose games? Seems quite immature. Why not something else, something a bit more intelligent, something a bit
Limited
more...
domain. Limited domain.
Awesome, alright. Games. The areas had limited domains, limited number of moves, limited number of rules, so they were easy to represent, so easy to test compared to maybe a more complex based game like chess that's got several moves. Now at that time they had to come up with a new type of programming language in order to represent knowledge. What's that type of language called? You give an example of one of the types and then you've been correct. Prologue's an example of it, but what's the kind of
Script.
nah, declarative? Yeah, so declarative languages like Prologue, yeah. Okay, so we come up with declarative languages that we should know a couple of wee things about, because we'll probably compare them to other ones. So it consists of facts and rules. And what's that really crazy? Yeah, no, I'm trying to get a description. The really crazy rule that allows you to implement something else again.
Recursion.
Recursion, right? Recursion. So not all programming languages are capable of involving recursion. But remember, some of the differences are that it doesn't consist really of different variable types or arithmetic operators that we're used to seeing in the scripting languages and used to seeing in the other languages that I've totally blanked. Names of them again. Oh god, it looks stupid, even more stupid than usual. Object-oriented languages and declarative, procedural and event-driven. Yes, got there. So after we talked about games, LXSS's, limited domains, we drew out the noughts and crosses grid, and we kind of looked at some other stuff we come back to later on with searches. We spoke about loads of different areas that AI is focused on, and one was this. What's that called?
NLP. Natural language
No,
processing.
yeah, natural language processing. And we had the cheat to remember the 4 steps in the correct order.
Bugs.
Rugs. Good, I need to sing the song for Aladdin, which I'm actually disappointed in.
I don't know this song.
I can show you the world. That one. Even though it's a
Sing it more.
carpet. We'll just watch it later on. So the steps are, what's the step at R actually called? Speech recognition. Excellent. Carried out by splitting up each of the words that have been read into their individual parts called phonemes. You
Understanding.
of what?
Image.
Natural
Natural
language
language
understanding. So it tries to make sense of what you're saying. Now, what's some of the problems that might occur for us trying to recognise speech at this point?
Background noise.
Background noise, excellent. Any others?
Accents.
Good one. Any others?
Like dialects from different places.
Good. Accents, dialects, all excellent.
Different
One
languages.
really important one. Different languages, I suppose. Yeah, but then that'd be accents, dialects, different words it doesn't recognise. Words are totally changing and evolving.
Ambiguity.
Ambiguity. Let's see that one. Ambiguity. Now, what stage is it that takes care of ambiguous sentences and ambiguous words? Words with multiple meanings, sentences with multiple meanings, sentences where you can't actually tell the difference between two things. What stage?
G.
So where you generate a response, that's when you then deal with it. The understanding stage needs to deal with the ambiguity, so it can what a response?
Come up with one. Generate.
Yeah, so natural language generation, where it comes up with the response it's going to do before what? What's the S? Speech synthesis, excellent. Okay, so when it like pronounces, it says back its response. So we also need to know a couple of different areas that this is used in. So what do we use natural language processing for? The one we watched the clip of, the translators.
Yeah.
So from French to Spanish, whatever it may be. Any others?
NHS 24.
What's that?
Oh no, that's I don't know if it's not NLP.
It's not NLP, yeah.
Expert system.
Expert system. Yeah, talking in a minute. Any others?
All your kind of things on your phone, like Siri, things like that.
Yeah, so voice control processors. So most devices are coming with the ability to use voice control, so it's good for users for hands-free. Also anybody that's possible disabilities can still use it as well. As well as that, we've got the sort of online stuff, phone-based ones, so phone up to book concert tickets, phone up to book cinema tickets, phone up for information on stuff. Rather than having a human answering the calls, you can have a natural language processing system in place there. And again, something like a ticketing system is a limited domain, so that's quite useful. We talked about image recognition, and we said the stupid phrase, "In summer, elephants organised idiots." So what are the actual names of these stages?
Image acquisition.
Yeah, so image acquisition. Yep. What else? Oops. Image acquisition. S. The image could be really blurry.
Signal processing.
Yeah, signal processing. So want to clear up the image. Remember, it could be a moving object that it's trying to recognise from still photos. It could be blurred. There could be a lot of background objects that you need to extract it from. We'll talk about the problems with it in a second. E.
Edge detection.
Edge detection, where it builds up a wireframe model of the actual object it's trying to recognise, and then it tries to
Object recognition.
yeah, it tries to recognise the object through object recognition. Now that's an important step. How does it attempt to recognise the object it's looking at? Let's get a picture of.
Compare it.
Compares it to what? Pattern matching, yeah, with what?
Stuff that's in its knowledge.
Good stuff is its knowledge base. Objects that's already been taught how to recognise, and it uses pattern matching and fuzzy logic to make that comparison. It basically just compares the image several times before it attempts to what the image? Understanding. Excellent. Okay, so again, uses of it. Any uses? If I say security, what would that one be?
Airport security.
Good for doing what?
Looking for terrorists.
Right, so recognising people, terrorists, missing people on web cameras and so on. It could be in manufacturing for parts on assembly line, things like that. And they also use them in robotics. So we'll put in here see others, because a lot of the areas that says others, my writing's just terrible. I mean, the areas like robotics that we'll talk about will have image understanding inside there. The other one with like satellite photo interpretation, weather one prediction is artificial neural systems, but it will need that as well. That really means that they're all combined. Now, what's some of the negatives, some of the problems that we have with recognising images?
Bloody.
It could be blurry, so we'll leave that, because signal processing should maybe clear up the blurriness, tidy up a wee bit as well. But exposure again should be taken care of with signal processing, so clean up the image. But even after you've done that, then we would look at the stupid images. So we've got multiple angles you could view it from, light and shadows. Again, some of it will be cleared up. Yeah, so try and clear it up in that. It all says obstructions. If you think of something that was to pick up pills on a construction line, or was picking up vegetables on a construction line, or something that's very busy, there'll be parts of objects laying over one another. So there's multiple angles you can look at it: light, shadows, obstruction. Those are plenty for us there. Next one we spoke about was expert systems, and there's quite a lot there, so we'll just maybe bullet point this. 3 parts of the expert system. What are they?
Knowledge base.
Knowledge base, yeah. i.e.
Inference engine.
User interface.
User
User interface. Which one of these is not part of an expert system shell?
Knowledge base.
Knowledge base, right? So an expert system shell, it does not have a knowledge base, which means we can create a knowledge base and we can have an expert system for anything that we want. Now, what are some uses of expert systems? Yeah, what does that tell you though? What does it do?
It can ask loads of questions
Yeah.
about symptoms and narrow it down.
Good. It recommends a course of treatment for yourself, so it's diagnosis. And another straightforward one is the whale watcher. that diagnoses, it recommends advice on what particular whale you could be looking at based on the properties you describe. And there's other parts to it, alright? It has a working memory to keep track of your answers, to keep track of the questions that have been asked to you. And there's two groups of people involved that create it. Who are they?
Knowledge engineer.
Knowledge engineer, really important. So that's the person who's an expert in creating expert systems, as well as all the domain who's experts, right? And it's really important we get that experts, because what's some of the advantages of it?
They'll never die.
It never dies. It's permanence.
The experts. It's made up of more than one expert.
Yes, several experts. And it can justify, which is to mean it can explain how and why. So how does that explain again?
How it came to the conclusion.
Good. How the system came to that conclusion and why explains.
Why it came to that conclusion.
Not the conclusion. It's to do with how it works. How does it work? What does an expert system do?
Asking questions.
Right, exactly. So they would just explain to you why it's currently asking you that question. It's to explain the path of logic it's gone down to generate that particular question. Right, and the inference engine is the one that deals with that how and why. And it would just look at the working memory and tell you how it came to the conclusion by telling you all the facts which are true. So we said uses, parts, who makes it, advantages, disadvantages. So we'll do artificial neural systems next, because they like to compare them.
You've not done a disadvantage.
For this one, have we got any disadvantages for expert systems? We'll talk about them with this actually, right? Because
people out of jobs.
this one here is an advantage for expert systems, but it's a disadvantage for artificial neural systems.
Could it put people out of jobs, but
People could lose jobs, yeah.
It can predict. It can predict.
No, prediction, yeah, it's not common sense. That's a huge one for everywhere. In fact, just put that right in the middle there. Nothing we talk about has common sense the same way that we do. Right, artificial neural systems, and then we're almost done. We need to squeeze in robotics, and we need to squeeze in searches. Alright, artificial neural systems consist of millions of, or thousands, hundreds, lots of interconnected
links.
There is links, but what are they linking up? Processors. Right, there's links that exist between the processors. They have inputs to the processors, they have outputs. Now each input is either a 1 or a 0. How could you make it so that it could be a 3 as an input? What would you change? So that it'd be a 1 that comes along the wire, but then the processor can interpret it as a 3. I don't know what that stupid diagram drawing is. By adjusting the weights, right? So we can increase the weights in order to get these artificial neurons to fire. Weights, links, layers. Weights, links, layers, inputs, outputs. That's it. Uses. Any type of prediction, so weather prediction. Stock market prediction.
What's the weights? What about the threshold?
That's the word I couldn't think of what I was missing. Yeah, the thresholds, good shout. Thresholds. Obviously, if you lower them, increase them, would stop it firing as easily and passing on the data. So this is a huge bit worth reading over. The other one is handwriting recognition for mail sorting. So it's quite an annoying job to read people's mail and put in the correct areas for further postage. Advantages are it's continually learning, it's improving, it's updating. But these are disadvantages for other ones, which is why I like to compare them. It doesn't have any justification features, but it's capable of learning new information. It's capable of improving and updating. Whereas once you create the expert system and software format and publish it, and you can send out updates for it, which allow people to kind of download any changes to it.
It's got a lifting function.
The other wee part is a hardware and software model they could ask us about.
Is that positives?
It's just how you could create them.
Okay.
When you're developing it before you've finished it, what would be the better approach to create it as? Software? Why?
So you can change it easily.
Change it easier, yeah, easier than going away and physically moving pieces of hardware, whereas you've got a software model, dead easy to change it and update it. Okay, robotics, we spoke about basically, I guess, their uses and the disadvantages and advantages of them. So what have we got? Bomb disposal,
AGVs.
disposal, AGVs, all the kind of exploration ones, so whether it's Mars, deep sea, water, recovery for people, deployed in military situations. Any disadvantages that they have, problems that they have? And we talked about how it would be difficult for them to plan a path. What type of situations do we continually run into?
Unexpected.
Good answer, John. Yeah, unexpected. So you can't possibly program it to be intelligent by programming it to how to deal with every situation when there's millions of situations that arise that we've never dealt with before.
So
but you use common sense.
So can you say it's got a limited domain as well?
Does it?
But you can only program it for one aspect.
Okay, yeah, I suppose if you're limited to bomb disposal, do you dispose of a bomb, right?
Easy.
It's quite. I know. Just
Cut the red one.
Cut the red wire. That's it. Adequate processing power. Yeah, we're talking about really complex actions it's carrying out here on its own. So that processing power up there with our sort of level of intellect as humans, as well as power supply. If you think we had one that was sent up to Mars, sent up to the moon, sent up wherever, how do you power it? So is it batteries, rechargeable batteries?
Cost.
The cost of it, it could be a really high cost as well. We talked about searches. So we talked about breadth first, and we talked about depth first. Right, so we had A, let's just make up random ones. Okay, so these are called, what was the H word that describes breadth and depth? Heuristics, alright? Heuristics. Now heuristics improve how quickly you can find a solution by reducing the search tree. Good. So they'll decrease the time it takes to find a solution rather than increase how quickly it can find it. Yeah. It decreases the search area, therefore it makes the searching faster. What's the problem called though that real world situations suffer from when you're predicting the next move in a game of chess or you're predicting responses to particular questions?
Too many.
Too many what?
Responses.
Too many responses, so we'd have a particular response called F, and further from that we could have too many responses after this. Now this is quite straightforward, but what if we had to go and model a real world conversation or any real world choices for doctors and so on? At any one time they must have millions of choices they can make. But what's that called when there's far too many branches at each level? It's far too complex.
Combinatorial explosion.
Good. Combinatorial explosion. And heuristics are what combat combinatorial explosion by cutting down the search space. Now the last thing we need to know is which one of these two guarantees to find us a solution. Which heuristic guarantees to find a solution out of these two? Breadth guarantees to find you a solution. Yeah, this guy less memory though, because it only needs to remember the current path from the source. This guy uses more memory, and it's giving me devil horn saying, yeah, he finds you the result, but requires more memory. So let's say, for example, that the goal state is at J. What order would the breadth first search visit the nodes?
ACF.
Yeah, ACF. Then what? GHJ. Alright, but if we were to draw out how the depth first search visits each of the nodes, you would think it takes more memory because it's going A to C to G, back up to C to H to C to A to F to J. But it uses less memory because it only needs to remember A, F, J. But it could get stuck in an infinite loop and keep down the same pathway all the way down here, or a solution could be F. Depth first search would take forever to find it, whereas breadth would get it a lot sooner. But equally, if G was a solution or something down this side, they can be lucky and get it really quick. However, we need to have some form of backtracking in there in order to not get stuck in infinite loops. And obviously, the big, huge part we've missed out is recursive rules and traces. Okay, so I'll put a big note on that. Traces could be up to 8 marks in the exam, which is a fair percentage when you compare it out to 140 marks. Alright, so we could be getting quite a few marks from that, as well as drawing a semantic net. Seen questions for that for 6 marks as well. And again, we've practiced them, they're straightforward enough. And this recursion. Now, what is recursion?
Something to be over and done over and over again.
It's done over and over and over again. Now, that could just be iterative, that could be repetition.
The same way.
The same way, better. Calls itself, yeah. The rule calls itself. Inception. The recursive rule, the definition of the rule, one of the sub-goals of the rule is the rule itself. Why is the order that the rule's in really important? Why is the recursive rule got to be after the indirect rule?
So it doesn't get stuck in there for
Good, yes, if the recursive rule came first, it would just call itself and itself and itself and itself, rather than calling the indirect rule first, which checks the get
So
out.
what goes first?
The indirect rule. The indirect rule. The direct rule is the one that calls itself directly. The indirect rule is the get out, if you like, the one that checks a simple fact. Okay, so tons in there and a lot we missed because we can't really do traces in a spider diagram. If we missed anything, natural language, image recognition, expert systems, artificial neural systems, robotics. The only one thing I can think of is embedded processors built into all of the hardware that exists, washing machines, microwaves, stores of programs. They're written in low-level languages. They're actually written in machine code for efficiency. They store the programs of what they're going to do. They're in cars, they're in cameras, they're in absolutely everything. And I can't think of anything else that we've missed at all. Anything, MD? Think you anything? Anything to clear? Obviously, try to summarise artificial neural systems in that limited space. It's difficult, right? There's a lot. I would recommend really reading up on them and making sure you know your links, thresholds, because I managed to forget it. Inputs, outputs, weights, that's a huge part. Make sure you're capable of telling us a couple of uses of each of the different areas of AI that we've looked into, and make sure you practice these. Alright, they're huge. And I think that's about us. We did do voice? We did do voice. Alright, anything else? Ask.